Hello, folks. I am Master Saib, or Dima Starodubtsev, and today I want to give a talk on the beast I called Biome Engineering. What is Biome Engineering? I asked GPT and he said that it is the art of designing living system in resonance with nature intelligence, not against it, okay? Moment, I will fine tune the sounds, okay? This talk is a part of a broader series of lectures on the building autonomous communities from our residents at Edge City. And we already give a talk on the story of Cyberia, the pilot we are building on Bali. We explain how we approach problematics around energy and water systems. We give standalone attention to soil heat and carbon topic, which we believe is one of the most important in building self-sustainable societies. And now with the next steps, we want to discuss the creation of highly efficient and resilient gardens. Okay. The purpose of this talk is, it's not to give you ready-to-use recipes. It's kind of impossible. The topic is so broad that you can take like months, years to research and understand it. Depending on it, the topic is extremely specific to the location you want to build your garden. Different climatic zones, different biome types. Different purpose of building. So actually, it's and also soil is very different in different places of the world. Something like 100 types of soils. So the complexity of building narrows down to the understanding that building biomes is extremely localized thing. So the purpose of this talk is more like give you a taste and inspire for you to give inspiration for you to build your own living thing. Someone is called it a garden, someone call it a forest. But before diving deeper, I want to give you a perspective on our background, why we are talking about that, and actually give you the sense of the scale we did before talking about that, okay? We moved off grid 2.5 years ago, and since then we identified something around 200 local species of plants. We make extensive soil research, during which we was able to identify like chemical structure, composition, and most importantly, the safety of the soil. We did birds research and identified almost 100 species. We did several times water research to understand the chemical and biological composition of water. And also we tried to build our own incubator. I will show you on the picture. It's something like 30 acres. It's this piece of land which we use specifically to experiment with different species. I find something like 500 species from all around Indonesia. Like we were focused mostly on the useful species, which can be useful in some sense, like food, cosmetics, energy, etc. And from these 500 species, 400 species were able to survive. 200 was kind of efficiently grow. And I think during this research, we identified something like 100 productive species we go into scale in our village for different purposes. Also, we did experiment with ships. we bought initially 10 sheep, and the population started to decline very fast. Something like 7 sheep were dead in like 3 months, and the reasons are that like actually we wanted to switch them from conventional agriculture to more free range behavior, and we end up that some of them were ill from the worms and parasites, and some of them were like actually didn't understand what to eat, and some kind of toxins and after that we start to we put them back into the stable, so that is basically the stable. It's not very big, and slowly we start to have growth and to sheep emerge. Slowly we start to learn how to work with them in a more natural way. So another experience is like regarding chickens, and chickens also like kind of the same. Most of them was dead from predators, but eventually, slowly, after like short decline, they start to adapt, and currently we have already new generation. Soon I think we will put it into like more productivity, like stage phase. Also, here I just want to show you the scale. We have something like 7 hectares of productive forest. It's like this stripe of land, yeah. So it goes from one mountain. It's 100 meters in width, yeah, but it goes almost from one hill to another, yeah. So on this 7 hectares of gardens, which was settled by previous owners, it was mostly coffee plantations, and we at this after 2 seasons we are able to collect 2 tons of coffee, our own coffee, full reserve for a year, and we have continuous very stable yield of avocado, taro, batat, vegetable fern, and the chayote is a local alternative to squash. Yeah, very beautiful thing, by the way. Also, we identified serious problems with growing banana and jackfruit, so we started to recover the way we cultivate them. And also we were able to learn how to grow greens, salads, and aromatic teas. In the end, we were able to produce something we called food box of Cyberia. It's complete food system, which consists of like 30 herbs, several roots, 10 fruits, meat from our neighbors, goat, chickens, also with the help of neighbors, honey, ginger, also roots, and fish from local lake. So basically here we are talking about that we were able to collect complete product thing in something around 2 years with the help of neighbors, yeah, which we are very proud. Just several pictures, yeah. So let's get down to biome engineering. We started to learn about the ideas something like 3 years ago, and thanks to different type of school of thoughts, I call them, such as permaculture, horticulture, agroforestry, regenerative farming, syntropic growing, a lot of like different sources. Just to give you a sense on what kind of research we did, it will generate for something like 1 minute. I want to show you our knowledge graph we built. But before, while it's rendering, I want to ask you several questions to understand your reason why you are here. Who of you have gardens? Uh-huh. Who of you also?
No, I used to work on a farm that followed permaculture practices
Mm-hmm. And you have here? In South Africa. Mm-hmm. Uh-huh. Cool. 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 How long? It's already. Mm-hmm. Interesting. Who of you have plans to establish their gardens, your own gardens? 1, 2, 3. Yeah, guy. 4. Okay. Good luck. I seriously wish you to succeed, and that's why actually we are establishing this course. So yeah, the research for more than 1,000 species. We touched something like 500 species. It's a huge knowledge graph. We were able to, to put and kind of understand what is important, what is not. So yeah, it's a huge work. And I want to share very dense ideas from what I learned during this path. Okay. So we have a lot of school of thoughts, but one really big difference. Yeah. In conventional agriculture system, you have one output and many. One output in permaculture system. You have in conventional agriculture you have many inputs, one output. In permaculture you have almost 0 inputs but many outputs. Yeah, and that's seriously affect how you work with nature, how you work with garden, how you work with garden. In agriculture, you mostly one of the most significant investments are fossil fuels, chemicals, waters. You spend a lot of money. Actually, I think it's most significant part, something up to 80% of the cost of conventional agriculture. And in the end, you have one crop that if fails, actually your operation fails. Yeah, so it's not resilient. It's destroy the soil. In nature, plants just can't grow alone. Okay, but conventional agriculture actually doesn't try to understand this important property, and that's the result why you actually need so many inputs to the process to have only one output. In the system we are talking about, it's actually provide almost 0 inputs, so the system is self-sustainable. And in the end, you can have the amount of outputs you choose to. In our gardens, we decide to scale. We put something like 50 species in production, which actually we expect provide us with all the scale we need for the food system: oil, starch, herbs, teas, salads, vegetables. Also very important part is cosmetics and aromatics. One significant thing we rely on is part of the energy system, so it's compost and biochar and wood. And also it provides a lot of fertilization because we kind of we grow fertilizers, and I will explain you how right within the system. Okay, So this is picture is like the most important thing you must understand that make significant change in understanding and shift from previous system to the future systems. Well, a lot of people talk about permaculture, never actually trying to give the idea how to make it like really profitable. Yeah, I don't believe that any technology is actually will succeed if you like not trying to understand how to move from just cool ideas and beliefs to something we call high margin stuff. Yeah, once you have the process that is high margin, it start to grow by itself. And I will give you like the most important idea I actually catch and will bet on during my research path. It was like, for me, it was like eyes-opening thing that farmers produce coffee and sell it for less than $1 per kilogram, but then when it goes to the coffee shop, actually it costs 500 per kilogram. Guys, it's just unbelievable. I'm serious. I'm serious. The margin is 600 times higher, and everything is lost by the way, like from the actually the coffee tree to the mouth of the consumers. So remember, when you drink coffee, you mostly pay for the last mile in this supply chain. In like farmers almost get nothing. In our case is avocado. Yes, our farmers sell avocado. It grows like wheat actually in our region. We never understand that avocado can cost like $5-10 per kilogram in retail stores. It costs something like 70 cents locally. But if you sell it as guacamole, you have something like 50, 60, $70 per kilogram of guacamole. So I came to a very important understanding on how actually, for what to build these biomes and permaculture gardens. The most important, I believe, thing is instead of selling raw things, the industry must switch to sell already full menu I showed you. Yeah, so it looks something like that. Yeah, when you put the stuff on the table, it's become like 2 orders of magnitude higher margin. Yeah, and this leads to I start to understand the model of my village. And for example, if I have like the tourist who can pay $100 per night per stay, if I offer him full menu with food, he can pay $200 per night with food. So if you analyze your structure of costs wherever you are, it's kind of one-to-one housing and food. So, and if you assume that you are not selling the raw products, if you assume that you are selling ready-to-use food on the table, in the plate, the margin is there, and I'm trying to learn how to embed this into business models of a village. For example, I want to share you one story about how Balinese people actually work with land. We have this default agreement we call Nandu. Nandu is when landowner share land with farmer, and when they split revenue 50-50. So basically, farmer provide labor, owner provide land, and when we split 50-50, once yield come. It require pretty deep trust within farmer and land owner, because it can take like 3-5 years while the garden takes off. But it works, and according to our research in our region, something like 80% of land is managed under these Nandu agreements. Yeah, but my idea to go further and put this kind of revenue share not on the land level, but on the cafe level. If you take this idea further and allow the system to allow to build cooperatives that actually provide the food directly to local restaurants. Actually, that could make sense for farmers because they can significantly increase their margin from their activities and also switch from these not very efficient old agriculture system that destroys soil to multi-layered, multi-species agroforestry systems. Okay, and according to my estimations, that could roughly increase the yield on land investments from average 8%, which I give examples, which is average on Bali, yeah, to something like 16% alone, just because it's provide better utilization for real estate, touristic, it's ecotourism, real estate. It's provide better vibe. You live literally within the garden. You can eat, and in the end, ends up in high retention for ecotourism businesses, which is also one of the more most important part of business modeling. So. Yeah, how to? I will discuss here only the first principles without going deep into details. So, in conventional system, you choose one crop, you choose one way to handle about crops. In nature, you see, you go to forest, it have all things baked into one system, yeah, and that's why I moved from agroforestry. All that I just think that it is biome, which is one thing that have really complicated circular relations within the system. You cannot plant fungi, but fungi is the only way to decompose remainings from your food production. You cannot put animals into the system, but you need manure to supply for trees. You can not do aqua systems like ponds, but actually, if you start to think about closed loop systems, the most efficient way is to put the fish in the system because it produces very efficiently a lot of NPK and other long tail elements, and can provide can be significant source of minerals for your garden and also be the source of proteins for your restaurant. So actually what I'm saying here is that we must switch the thinking from one species to the complete system, which include everything what is needed to mimic the nature. Because it's already worked, we don't need to invent, we just need to learn how to replicate the system. And it can work pretty efficiently. The next component in this, I think one of the biggest important things in this is biochar. I gave a standalone lecture on this. Yeah, it's here. I will not stop, but just want to remind you that it is probably the key component into making the system really not requiring external inputs, because it is the way to get continuous flows of elements from the rainy waters. Just filter it, place it, and put it in production for your garden. Another important property is that actually you must avoid digging in the garden, and the reason is the fungi. That is the mushrooms everyone talking about, the big mushroom which live inside our planet. Everyone see under mushrooms and feel it. So this mycorrhizal network is everywhere in the soil, and that is the most powerful internet which exchange nutrients for anything that lives on Earth. Although it's only occupy the lower, like 1 to several meters of the Earth surface, the scale and the amount of this mycorrhizal network is enormous. It was demonstrated that thanks to this mycorrhizal network, actually, the plants in the forest are able to exchange nutrients on demand, depending on their needs, from mother trees to more like smaller plants and back. Don't confuse this mycorrhizal network with mushrooms. Mushrooms are fruiting bodies of mycorrhizal network. Okay, so actually that is the most foundational thing in building efficient gardens. Once you dig the soil, you destroy mycorrhizal network, and it regrows in several years. Once you destroy mycorrhizal network, it stops to provide nutrients within your system, and basically not allow you to build the system I'm talking about. Okay. This beautiful picture is just an illustration of happens underneath what happens underneath the soil. So it's the whole living world. When you put some fertilization chemicals, you mostly kill all that's beauty. When you not cover the soil, it's become dry. The bacteria become dead in several hours after drying out the soil. So this upper layer of soil is probably the most important for fertility. So common rules is not to dig, is not put chemicals, and let the microbiome of biome of soil to grow and on a continuous basis increase the fertility of your garden. Okay, another important principles, I would say, it's pruning. I just forget to put it here, but it's interesting thing. Pruning is when you cut some part of the tree, the shrub, doesn't matter. What happens during this process is that actually the ratio between the body and root become lower. So actually the plant is able to deliver more nutrients per cubic centimeter of the body and start to grow faster. Okay, and become more healthier, have better immunity, and so on. So it was experimentally proven that actually the gardens which are heavily pruned every 12 months reach enormous productivity gains. Okay, so actually when you are pruning, you are not actually destroying the plant. It's release vice versa. It increase the speed of its natural life cycle. It release hormone of growth, and the garden just become healthier and more productive. Yeah, another important first principle is building in layers. Yeah, so here we describe the system of layers, and the layers. Moment. The layers is a way to use the space more efficiently. Yeah, so you commonly under the soil you have 5 layers. The plants which are like small shrubs, when you have 2-meter shrubs, which you can, like with small berries, when you have higher, like 4 meters trees, which you can pick up with sticks or also with hands, like avocado, for example. When you have higher trees, which can contain bigger stuff, for example, jackfruit in our case. And also you have like 20-30 meters trees, which provide, for example, resins or some aromatics or some function to your forest. So, and also you have the most lower level, which I call carpet, which covers 10 centimeters of the soil and contain mostly grasses, but is most aromatic grasses, but is likely the most productive layer. So you have 5-6 layers. On each layer you can grow different plants, which actually give you ability to switch even the most simplistic systems from like 3-5 species to like 20 species easily, because you can put 2-3 plants on each layer and combining them, having 20 species without actually competing between any competition between them. Moreover, it's observed that high density planting now is like kind of become mainstream high density planting. Why? Because plants, when you put them in very competitive environment, they start to compete, and that results in faster, better growth and more healthy plants. So you put them in layers. You think about stratification. Stratification is understanding that how natural system evolves from bare rocks to huge abundant forest ecosystems. Yeah, so like it starts from mostly herbal layer, when herbs is herbal layer mostly overcome by pioneer species which can grow fast, but after that they are mostly succeeded by apex species which replace them. So it's not that you are building the system that always becomes static. Yeah, you think how it evolve or over the time and switch with years from simple pioneer species which provide more biomass to your ecosystem to more productive century-long system. Okay. The most fascinating thing about this permaculture and all that school of thought is that plants have features. Yeah, plants have features and can serve their specific role within the ecosystem. So I actually tried to identify the types of roles that plants can have, and it turns out something like 20 roles, but I will focus on several, the most important one, without which you will not be able to build the ecosystem I am talking about. The first most important is nitrogen fixers, which fix nitrogen from the atmosphere into the soil. If you try to, I put here almost all nitrogen fixers which are work in my tropical, subtropical environment. I don't think I have here something for temperate forests. But anyway, it's not very populous category of plants. So I was able to identify only something like 50 species which produce nitrogen, and only like 10-15 which produce nitrogen very efficiently. And out of this like 10-15, only 2 or 3 can provide really important goods for the ecosystem. So I end up using, for example, Caliandra and Inga, mostly for, and Casuarina. 3 trees I choose for my ecosystem to fill out this important function of nitrogen fixing trees. Okay. Another important category is dynamic accumulators. they have this important property like long roots which goes up to 5 meters to the soil and suck nutrients from lower layers of the soil, and when after decomposition these nutrients become available for the plants on top layers of the soil. So we use comfrey mostly for this, and it's kind of universal dynamic, the most efficient dynamic accumulator, which grows everywhere, I think. Yeah, it is a really important part of our ecosystem. Another category is attractor. So you must put something that have flowers in your ecosystem, because that attracts birds, that attracts bees, that attracts insects. So everything that flies actually can come, visit it, and pollinate it. Yeah, without this category of plants, you will not be able to pollinate your gardens efficiently. And the fourth was important, probably category is I call them gourds. It's mostly aromatic plants which actually protects your plants from pests, from insects. You can think like about mint, lemongrass, rosemary, which have this, like strong aromatic properties that repel. So they are repellents. They repel the undesired insects and the life forms from the plants. Yeah, so you configure these four types of plants, of roll plants, to and add where the actually plants you want to grow for your needs. And combined, they can form this extremely efficient ecosystem that don't need external supply, no fertilizer, nor pesticide, and so on. So I start to think why so beautiful ideas like wasn't able to actually to reach out broader masses. Why like permaculture is almost 50 years known, why we are still don't have this on a scale. And it turns out that this scalability problem, like in blockchain, does make sense. Actually, it takes years for the farmer to build highly efficient permaculture forest around his house, but it took years, enormous effort, and it's like kind of extremely specific and customized thing. So basically, you when Joy start to think how to teach people to manage gardens that contain more than like 50 species, we wasn't able to find easy solution. Okay, and so we are actually on the and still we don't understand how to do it. Okay, but we have a serious will to do that. So we after 2 years of research, we just started to build new generation of like our gardens that use grids, that use strict scheduling of maintenance, which use like this requirement to log all operations they do, to better analyze and optimize their behavior on the bed, yeah, in the garden. So hopefully we will. I have a serious feeling that it's certainly possible with proper engineering will to find out how to build these like super productive gardens on a scale and maintain them on a scale without needing very like localized specific requirements, so people can buy ready-to-use gardens and just maintain them like by living there. Because it seems that the biggest bottleneck for people to adopt this is this requirement for, to learn so much stuff always in different places, new stuff. No one can give ready-to-use solution, but if you build in one region, you can actually scale it. It's easy to scale within one region. And now I'm talking just how to scale it within the region, but taking like these first principles, you can go to different regions, spend like 1-2 years to learn how to do that, and can scale within this region, okay? So that is my belief that it's possible to scale, it's possible to make extremely high margin. And in summary, like my modeling shows that one simple family needs are something around 20-30 hours in tropics and subtropics, and probably 1 hectare in regions with winter. And it turns out that life, like the gardens which like work all year around, are just extremely more productive. So it could take 3 years to set up. After 3 years, like we spent 2.5, it's become easier for us after this time. So after 3 years, it's become easier, yeah, to maintain, to work with it. Like I already can predict some stuff. And some short advices that the simple and the most important advice nobody ever listened to is that when you start to build your garden, don't spend time on experiments, go around, look what is growing there, take it, find out how to grow it better. Yeah, don't try to, grow new stuff. First, grow the stuff which is already known to grow there. You will spend a lot of effort, a lot of money. It's the most important thing. Second is that, like, do one small step at a time, and I hope you will succeed. We will succeed in recovering the soil, regenerate the ecosystem that was damaged right now on Earth and eroding, degrading very fast. So the hope is here, and yeah, I think I'm done. Connect. We have this group, Cyberia. They have this group on Telegram. If you want, scan this and join. So yeah, I'm ready to questions.
You did this large research about everything, but what's your vision on the monetization? I mean, you want to do it like kind of open source to let everyone to access this data, or you want to do this like white label to let people to open their own like cities worldwide? Like, what's your vision? Because
you mean behind Cyberia or this data set, or like what?
Yeah,
what
yeah. You did this research how to build your garden and so on. So
researches will always become like everything we generate, we will put in open source, share the knowledge graph, invite people to learn. We will certainly run this kind of pop-up cities, which will require some payment to participate in building, learning how to build real gardens and houses. So it will be kind of training educational program. Also, we are going to provide franchise for city builders around the world. So like it's kind of layered thing, but the information we would love to share, so everyone without actually any limitation can build and recover soil, which is the ultimate task of what we do.
okay, thank you.
Hello, my question is around soil recovery. So you started your project in a region where there was soil already, which was kind of healthy. Could you speak a little bit to like soil which is unhealthy and like which has been contaminated?
Thank you. We, out of 37 hectares we acquired, something like 7 hectares we find out like extremely damaged. by conventional agriculture. I can, for example, I can show you lab results, yeah. And I did here several sites. One is this. This one is coffee, synwood, and edem. 3 sites I analyzed. And for example, you see here mercury. Yeah. So in the sites that was with agriculture, you have this like 7 and 13 ppm of mercury. In the site that wasn't under agriculture, you have 0 mercury there. So actually, we started this dam site, experimental site, on the damaged soil, without actually understanding that. Yeah. After that, after analysis and like experiments, we just decide to now kind of scale the gardens on already like 29 hectares we have undamaged, while building on the damaged stuff, something like recovery, like not actual or propagation system. So it's less about the food system, but more about functional system for propagation or like show off and so on. Because we find out that the growth rate on damaged soils are like significantly lower, the quality of greens are lower, and also I believe we did have our health problems when we start to eat these salads. Okay. I mean, for cereals, I felt intoxication symptoms, strong one while I stopped to consume it. So right now we stop actually to collect the food from the sites we started initially, and now moved in the like productive things into not damaged soil. So we are kind of happy that we have most of our soils undamaged. But yeah, I think that's answer your question.
Hello, is this on? You might have covered this in a previous talk that you gave, but I was wondering if you are planning on like capturing water specifically to build like your aquifer on your land.
We already do it. I mentioned that is part of the system. It's not a question on, I will repeat, it's not a question on like how much you water want to store. You must store like as much water as you can. So we are on a continuous basis at ponds, store their water, put their different type of vegetation, fish, and so on, and use it and as water storage and as the way to feed our gardens if the droughts come in. So yeah, kind of multi-purpose system we like build on continuous basis.
Okay, thank you.
I was curious, where are you sharing this information somewhere publicly that?
Of course, this is a knowledge graph. You can go to cv.land and find out everything I showed you in the knowledge graph is public. We kind of updated. Well, like consider it as just notes. We don't guarantee the quality of the information we're working. But for example, here you go to Edge City Residency. You will have this. Yeah, with some, and this is about soil. This is today lecture, Biome Engineering. So yeah.
All right, thank you.
Gotcha. And this is knowledge graph of Cyberia project. So like it's continuously developing. So learn about the stuff and join us in developing the stuff. So, okay. Yeah. Okay. If we don't have any questions, I will list this my personal X. If you want to connect me, not only regarding the biome engineering and sustainable city building, but also about weird stuff from like cryptography, privacy, weird decentralized AI, collective intelligence, like the most weird stuff actually you could find, you probably will find within my Twitter, because I'm continuously researching cutting edge technologies for a decade already, and kind of the edge with you. Thank you.